everyone, welcome back with Mrs. Struble. In this video, we're going to continue our transformations unit, and we're going to talk about reflections. I've got my little friend Blue here. I don't know if you've seen Blue's Clues, but Blue's going to help us out as we discover and find our clues to determine what reflections really are in math, at least as far as the coordinate system and figures are concerned. So, what are reflections? Well, reflections, most of us kind of got the big idea, you look in the mirror and what happens? If I'm wearing a shirt that says something, those letters are flipped. So that's exactly what we call reflections in math when we're dealing with figures and them they get flipped, okay? So reflections, also known as a flip. What happens here is a reflection is a transformation. It's a change to a figure. So it's a transformation in which a figure is reflected. It's the word, the name, right? Oh, pardon my bad handwriting here. It's basically reflected about a given line. Now, this line could be the x-axis, it could be the y-axis, it could be the origin, or it can be x equals 2 when you get into more advanced reflections, okay? This line that the figure is being reflected about has a special name as well. It's called the line of reflection. I know, very, very unique name. I have no clue how they even thought of such a unique name, right? But that is our line of reflection, okay? So let's talk about what happens. When we have a figure and it is reflected, what does that really mean? What happens? To help us go through and discover this, I surely hope that by now you have gotten out your handy dandy notebook. Yay! Okay. And if you haven't done so already, please get out that handy dandy notebook. Okay, take these notes along with me. That way we can all be at the same page. Okay? All right. Now that fun's over, let's go ahead and continue on and discuss what happens when we reflect a figure. Okay? Because the line of reflection can depend or vary, different things can happen depending on the different line of reflection. The main three reflection lines that we're going to talk about is the x-axis, the y-axis, and the origin. So what happens when a figure is reflected about the x-axis? And it turns out when a figure is reflected about the x-axis, the y value, or the y coordinate, I should say, changes its sign. So if it's a -2, it becomes a +2. If it's a +4, it becomes a -4. It changes its sign. Now, obviously, 0 is not affected by that because 0, well, the negative of 0, 0 is a neutral number, so there is no sign, it just remains 0, okay? So what happens if it's reflected? That's not an L, okay. Reflected about the y-axis. And I have a lot of faith in this group. I think we can kind of figure out, hey, if it's reflected about the x-axis and the y value changes, then if it's reflected about the y-axis, the x-coordinate must change, and you would be correct. The x-coordinate is the value that changes signs. Okay? And once again, if it's negative, it becomes positive. If it's positive, it becomes negative. So that's what I mean by it changes sign. The last line of reflection that we're going to discuss is a figure being reflected about the origin. Okay? So if a figure is reflected about the origin, I'm pretty safe in hoping that somebody has figured this out. Both the x and the y coordinate change signs. Okay. Now, if you'd like to, that doesn't really clarify things much. You could say, well, the ordered pair, for example, oops. For example, the ordered pair 5, -2, if it is reflected about the x-axis, then the y value would change. So it would become -5, -2. Okay, so to represent that change, we do a little squiggly here. See if I can get it down. Just gonna do a little squiggly, and then -5, -2. Okay, and that means the original ordered pair 5, -2 was translated, and now it's -5, -2. And we now know that the translation that happened or that occurred was a reflection about the x-axis because the y value was the only value that changed the sign. Okay. All right. Now, hello, Blue. We have Blue here. She's a really clue-loving dog. Hopefully you've met her. If you haven't had the pleasure of meeting her, you've met her now. So on Blue, I have graphed her on a coordinate system, and she's going to help us in reflecting. She's going to get reflected about the x-axis, the y-axis, and the origin to kind of understand what is happening. So as you can see, she is in the second quadrant. Now, if you don't remember your quadrants, they're in Roman numeral 1, 2, 3, and 4. Okay, now let's start labeling some of these points that I have located on her. That's point A, B, C, D, point E, F, and G. And remember, when we're using points on a coordinate system, we're using capital letters. This is where those capital letters come in play, ladies and gentlemen, in math. All right. So making a quick list here, we have coordinate A is at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, wait, 5. Yeah, 6. Just double check one more time. -5, 6. Okay. B is in the location of -1, 4. C, -1, 3. D negative 3. Oh, come on. 1. 6. E is negative 6, 1. And you get it from there. So we're just going to kind of omit G and F from this little experiment or exercise here. Okay. All right, so we have 5 points. Let's go ahead and first reflect them about the x-axis. If we reflect them about the x-axis, this is the x-axis reminder. What that means is we're basically essentially folding this drawing at the x-axis, and we're going to trace blue on the other side of it. Okay, so if I am reflecting about the x-axis, remember the y value changes sign. Nothing else changes. So A is going to be negative 5, negative 6 now. So where it once was here, now it's going to be down here, right there. So that's our new A, or A prime, okay? And then where B once was negative 4, 4, or excuse me, negative 1, 4, it is now negative 1, negative 4, right there. Okay. C, and remember this is a reflection in the x-axis. Go ahead and write that down. Hopefully you've grabbed a paper and plotted these points. You don't have to draw blue by any means, but you've got these points plotted and you're following along. If not, go ahead and pause and you can keep going with, continue with me when you're ready. Okay? Now, I'm going to go ahead and stop here. If you notice, B was on top at first, and now B is on bottom. What happened? Well, because we reflected blue about the x-axis, or reflected a figure about the x-axis, it ends up becoming upside down. So where blue once looked like this, now she looks like this. And is approximately, hold on, move her just a little bit that way, right there. Okay, all right. So that's how you would successfully translate a figure about the x-axis. Oops, put those dots back in there. Figure kind of covers them. All right. And you can figure out D and E from there. All right. So what would it look like in the y-axis? So reflecting blue about the y-axis, we're going to do that one in in they. That's funny. In the y, using green here. Okay. So again, we're using the original coordinates. If we're reflecting about the or about or in the y-axis, the x values are going to be the ones that change to their opposites. So where we once had negative 5, 6, we will now have positive 5, 6. Okay, so we had negative 5, 6. The x is the one that changes now. So we'll have 5, 6. And B, I know that looks kind of confusing right there, but this is what A prime will be in this case. And then B prime is going to be 1, 4. C is going to be 1, 3, and hopefully you kind of understand it from there. So what would blue look like in this case? I'm just going to rewrite these to the side here, which is where I should have put them in the beginning. computer's going dead here. It's wanting to be a little slow. Oh no. All right. The y-axis. All right. And this is where that figure would simply just flip, but instead of flipping vertically like it did, it'll flip horizontally. So where blue looked like this, she is now going to look like this. Okay? And the point A, the new point A would be here. So there would be our A prime in this case. Our B prime would be in the location 1, 4 right here. C prime right there. Okay. And that's how she looks. So she ends up in quadrant 1 when she started in quadrant 2. Last but not least, what happens if we're reflecting a figure about the origin? When we reflect about the origin, both coordinates change signs. Okay? So if you know your coordinate system here, quadrant 2 is negative positive. So at negative x value, positive y value. The opposite of that, the complete opposite of that would be positive x value, negative y value. It's going to end up here in quadrant 4 if you haven't put that one together. The question though is how is she going to look in quadrant 4? Okay? Keeping in mind both points change signs. So let's write this down. And like I said before, you have a little more space in your notebook. So hopefully you're just doing 4 lists, the original x-axis, about the y-axis, and then about the origin or in the origin's direction. Okay. All right. Point A was negative 5, 6. Now after the transformation will be 5, negative 6. Come on. B was negative 1, 4. It's going to be 1, negative 4. C is going to be 1, negative 3. Okay, and we'll just go ahead and just do those first 3. That's what we've been doing. So what is blue going to look like? Well, let's go ahead and graph them. 1, 2, 3, 4, 5. 1, 2, 3. There's our A. You'll notice I'm using color coding. I like using color coding because we're doing 3 different reflections based on one figure. That could be kind of confusing, putting prime and then double prime and then triple prime all over the place. So I just use color codes. B is 1, negative 4. C would be here. All right. So this ear remains close to the y-axis no matter what. Okay. So blue looked like this. After we translated her about the origin, she's going to look something like that. Okay. All right. I hope this has helped. What you need to do is go ahead and click on the next page in your Canvas module. Go ahead and try those practice problems. Be sure that you're checking as you go. And we'll see you next time.